Alright guys, couple of things I need to talk to you about really quickly. This is for Algebra 1. There's a change in attendance. I have to start marking attendance daily, whether you are in school or virtual. Alright, so here's what's going to happen. Some of you already know this. Miss Holly and Mr. Massey talked to you about this, but what you need to understand is in Infinite Campus, if you are virtual, there is a way for you to mark that you are participating daily. Alright, so here's what you're going to do. If you have access to Infinite Campus, then I need you to go in daily and mark your attendance. Alright, there's a little box that says participation. You're going to check it, and that is a check-in for the day. If you do not have access to Infinite Campus, then you have got to find a way to check in with me daily. Email, something, Google Classroom, some way, somehow, I need you to check in with me. Because if you do not check in and have not marked your attendance, then you will be counted unexcused absence. Okay? Now, if you check in with me, or you go in and mark participation for the day, and I do not get your work, it will be changed to an unexcused absence. So if you don't turn in your work for the day, then you will be marked unexcused. I can go back and change that 2 weeks down the road. When I'm grading work and I get your work and you don't give it to me, it will go back and be marked unexcused. This week, I am working on marking everybody present because I know this is new. But once again, if I do not get your work for the week, you will be marked unexcused. And guys, those unexcused absences do go towards truancy. So you need to make sure that you are marking your attendance, or you are checking in with me somehow daily to let me know that you are working, and I will mark you present. If I go back and I do not have your work, you will be marked absent. The other thing that I need you to know is if you are not showing your work on your assignments turned in, you are not going to get credit for them. You must show me all work that you are doing, every step in solving those problems. Alright, this is important. Alright, so lesson 18, equations involving a variable expression in the denominator. We're going to look at that. So our goal today is to be able to interpret equations as two equations joined by and. We're going to find solution sets for this new system of equations. Alright, so we're looking at a new type of equation we have that we have not done yet. Alright, so let's look at our opening exercise. It says Nolan says that he checks the answer to a division problem by performing multiplication. For example, he says that 20 divided by 4 is equal to 5 is correct because he knows 5 times 4 is 20, and 3 divided by 1/2 is equal to 6 is correct because 6 times 1/2 is 3. Using Nolan's reasoning, explain why there is no real number that is the answer to the division problem 5 divided by 0. Alright, so why is there no real number that answers the division problem 5 divided by 0? So think about this. He said that 20 divided by 4 is equal to 5 because 5 times 4 is equal to 20. Notice that he's taking his answer and multiplying it by whatever number he's dividing by. Alright? 6 times 1/2 is 3. So what they're saying is 5 divided by 0 is equal to something, and we'll let that be x. So is there any way that x times 0 would give me 5? There is no number where x times 0 would give me 5. Quinton says that 0 divided by 0 is equal to 17. What do you think? Well, let's think about this. While it's true that 0 times 17 is equal to 0, okay, we're using the same process that Nolan used. So while it's true that 0 times 17 is equal to 0, the problem here is that actually 0 divided by 0 could equal any number. If I am using Nolan's reasoning, then I can actually say 0 divided by 0 is equal to 5. 5 times 0 is 0. Alright, so I can use any number here. Mavis says that the expression 5 divided by x plus 2 has a meaningful value for whatever value one chooses to assign to x. Do you agree? Well, let's think about this. Let's say I put 5 in there. 5 divided by 7 is equal to 5 sevenths. Let's say that I put 0 in there. 5 divided by 0 plus 2 is 2. So 5 divided by 2 would be 2 and a half. But what happens when I put negative 2 in there? If x is equal to negative 2, I end up with a 0. 5 divided by 0 is not a meaningful value. Alright, so no, the expression does not have a meaningful value when x is equal to negative 2. Alright, meaningful value, that means that I have a value. I have something that I can say. Benoit says that the expression 3x minus 6 divided by x minus 2 always has the value 3 for whichever value one assigns to x. Do you agree? Well, let's look at this. What if I put 0 in there? Let's check this out. So 3 times 0 minus 6 over 0 minus 2. I end up with negative 6 over negative 2, which is 3. Let's put 1 in there. So I get 3 minus 6 over 1 minus 2, which is negative 3 over negative 1, which is 3. Let's put negative 1 in there. So negative 3 minus 6 over negative 1 minus 2. So that's negative 9 over negative 3 is 3. Let's put 2 in there. 6 minus 6 over 2 minus 2. Uh-oh. Do I get 3? Alright, so the expression does equal 3. For all values except x is equal to 2. All right? All right. So let's look at this. It says rewrite 10 over x plus 5 as a compound statement. So let's rewrite this as a compound statement. If you remember compound statements, and we are looking at, what we've been looking at is and or. But if you remember, I told you that we are looking at joined by and. So let's think about this. All right, so my original statement is 10 over x plus 5. And what can x not equal? X cannot equal negative 5. Because if x equals negative 5, then I end up with 0 on the bottom. So that is my compound statement. Consider x squared minus 25 over x squared minus 9 times x plus 4. Is it permissible to let x equal 5 in this expression? Well, let's think about this. What would happen on the top? If x were 5, I would get 25 minus 25. Is it okay to have 0 on the top? It is. All right? If I let x equal 5 on the bottom, I get 25 minus 9 times 5 plus 4. So I wouldn't equal 0 on the bottom, so that would be okay. So yes, because I would end up with 0 over, and if I work this out, 25 minus 9 times 5 plus 4, I actually get 144. All right, and we know that 0 divided by any number is 0. I can have 0 on top, I just cannot have 0 on the bottom. Is it permissible that x equals 3 in this expression? Well, let's look at what happens if x equals 3. I get 9 minus 25, so I'd end up with a negative number on top. That's okay. I'd end up with negative 16. So let's see what happens here. So 3 times 3 is 9 minus 9. I get 0. And 0 times, it doesn't matter what's over here, 0 times whatever is 0. So I would end up with negative 16 over 0. So no, I cannot do that. All right? So it says, give all the values of x that are not permissible in this expression. So I know right now that x cannot equal 3. We've already proven that. All right, let's see what else it can't equal. What else could x equal here that would give me 0? Negative 3 times negative 3 would be positive 9. So x cannot equal negative 3. Let's go over here to this set of parentheses. What can x not equal? Because it would give me 0. It cannot equal negative 4. All right? So these are the 3 numbers that x cannot equal. That is not permissible because it would give me 0 on the bottom. All right? Let's look at example number 1. Consider the equation 1 over x is equal to 3 over x minus 2. Rewrite the equation into a system of equations. All right? So let's think about this for just a second. I need to figure out what x cannot equal. So I've got 1 over x is equal to 3 over x minus 2. And x cannot equal, well, what can it not equal here? It can't equal 0. It can equal any other number there, but it can't equal 0. And let's go over here to this side. It can equal any number except negative 2. I'm sorry, positive 2. So x cannot equal 2. So there is my system of equations. So to solve the equation for x, excluding the values of x that lead to a denominator of 0. All right, so how am I going to solve for x? Well, we can do this a couple of different ways. You can try to find a common denominator, or because I am dealing with variables here, I'm going to show you the simplest way for you to solve this. You are going to cross multiply, which is the exact same thing as what you would do if you were finding common denominators. So I get 3 times x is 3x equals 1 times x is x, and 1 times negative 2 is negative 2. And now I solve this. Subtract x from both sides. 2x is equal to negative 2. Divide by 2. X is equal to negative 1. So my solution set is x is equal to negative 1, and x cannot equal 0, and x cannot equal 2. So I would write it like this. My solution set would be negative 1. Okay? But I have to make sure that I'm saying that x can't equal 0 and x cannot equal 2. Because we've already figured out that that would give us a 0. Alright? Example number 2. Consider the equation x plus 3 over x minus 2 is equal to 5 over x minus 2. Rewrite this as a system of equations. Alright, so originally, x plus 3 over x minus 2 is equal to 5 over x minus 2. And x cannot equal, well, looking at here, x cannot equal positive 2. It can be any other number. Same here. It can be any other number except for positive 2. So there's my system. Alright, so now we're going to solve. Alright, so we're going to do the exact same thing. Okay, we're going to solve this system of equations here. So we have to multiply. So 5 times x is 5x, and 5 times negative 2 is negative 10, is equal to, I have to multiply this. So x times x is x squared. X times negative 2 is negative 2x. X times 3 is 3x. And 3 times negative 2 is negative 6. Alright. And we're going to bring everything, because I'm dealing with an x squared. Let's see what we can do to simplify this a little bit. Combine my like terms here. Alright. And let's go ahead and set everything equal to 0. So we're going to take this 5x over. And I get negative 10 is equal to x squared minus 4x minus 6. I'm going to take this 10 over. So I get 0 is equal to x squared minus 4x plus 4. Alright. I'm going to factor it. So x times x gives me x squared. This is a negative positive. So that means both of my answers have to be negative. And I need to be able to add my factors of 4 to get 4. So I'm going to do 2 and 2. And I can say x minus 2 is equal to 0. X minus 2 is equal to 0. X would be 2. X would be 2. So my answer is x is equal to 2 and x cannot equal 2. So here's my problem. If x is equal to 2 and x cannot equal 2, then my solution set is empty. All right, which means there is no solution here. I have no solution because the only answer I got is the one thing that x cannot equal. All right? All right. Let's go ahead and look at exercises 3 through 11. And let's talk about what we can solve these. So it says rewrite each equation into a system of equations, excluding the values of x that lead to the denominator of 0, and then solve the equation for x. All right, so we're going to kind of go through these really quickly. So I've got 5 over x is equal to 1, and what can x not equal? X cannot equal 0. That is the only thing that will give me 0 on the bottom. All right, and so now we're going to solve it. This is the same thing as 1 over 1. Cross multiply. 1 times x is x. 1 times 5 is 5. So x equals 5. So I have my solution set is 5. Okay? All right, number 4. So I have 1 over x minus 5 is equal to 3. And what can x not equal? Well, the only thing that's going to give me 0 in my denominator is x cannot equal 5. And now we're going to solve this. So 1 times 1 is 1. 3 times x is 3x. 3 times negative 5 is negative 15. Add 15 to both sides. I get 16 is equal to 3x. All right. Divide by 3. X is equal to 16 thirds. And x cannot equal 5. So my solution set is 16 thirds. All right. All right, let's look at this one. So I have x over x plus 1 is equal to 4. And what can x not equal? It cannot equal negative 1. Now I'm going to multiply. So x times 1 is x. 4 times x is 4x. 4 times 1 is 4. All right. Subtract my 4x. I get negative 3x is equal to 4. Divide by negative 3. So x is equal to negative 4 thirds. And x cannot equal negative 1. So my solution set is negative 4 thirds. All right. Let's look at this one. I have 2 over x is equal to 3 over x minus 4. And x cannot equal, well, it can't equal 0 here. Let's go over here. X cannot equal 4. All right? So in this case, there's 2 x's cannot equal because there's x in both denominators. All right? So that's my system of equations. Now let's multiply. So 2 times x is 2x. 2 times negative 4 is negative 8 is equal to 3 times x is 3x. Now I'm going to solve. So negative 8 is equal to x. So x is equal to negative 8. And x cannot equal 0. And x cannot equal 4. So we're good. So my solution set is negative 8. All right, let's look at this one. So I have x over x plus 6 is equal to negative 6 over x plus 6. And x cannot equal, what is the only thing that's going to give me a 0 here. In either side is x cannot equal negative 6. All right. So now let's solve it. So I have negative 6 times x is negative 6x. And negative 6 times negative 6 is negative 36. Is equal to x times x is x squared. X times 6 is 6x. All right. Add 6x. So I get negative 36 is equal to x squared plus 12x. I'm going to add 36 to both sides. I get 0 is equal to x squared plus 12x plus 36. All right, when I factor this out, x times x gives me x squared. Because it's a plus plus, that means both are going to be positive. And then I need to be able to add my factors of 36 and get 12. So I've got 1 and 36. I can't add those together to get 12. I've got 9 and 4. 9 plus 4 does not give me 12, but 6 plus 6 does. All right? So if I set x plus 6 equal to 0, x would be negative 6. But look what I said x cannot be. So the solution set is, there is no solution, or it's an empty set. All right, because the one answer I got is the one answer it cannot be. All right, let's look at this one. So I've got x minus 3 over x plus 2 is equal to 0, and x cannot equal what? Well, in this case, the only thing that x cannot equal is negative 2, because it would give me 0. All right, so now I'm going to solve this one. So I'm going to, it's the same thing as 0 over 1. So 1 times x is x. Negative 3 times 1 is negative 3. And 0 times x is 0. And 0 times 2 is 0. So now I'm going to add 3. And I get x is equal to 3. And x cannot equal negative 2. So my solution is 3. Okay? All right, number 9. Let's look at this. I have x plus 3 over x plus 3 is equal to 5. And x cannot equal negative 3, because that will give me a 0. All right, that's the same thing as 5 over 1. Let's multiply. 1 times x is x. 1 times 3 is 3. Is equal to 5 times x is 5x. And 5 times 3 is 15. Subtract your x. 3 is equal to 4x plus 15. Subtract your 15. I get negative 12 is equal to 4x. Divided by 4. X is equal to negative 3. Look at this. It says x cannot be negative 3. So there is no solution here. Okay? Number 10. So I have x plus 3 over x plus 3 is equal to 1. And x cannot equal negative 3, because I will get 0 in the bottom. All right. So then let's multiply. So I get x plus 3 is equal to x plus 3. Guys, here's the one thing you need to understand. When I have the same thing on both sides, and notice it's x plus 3 and x plus 3, that means I can put any number in for x and it will work. All right, except the one thing we said x cannot equal, which is negative 3. All right, so in this case, it's all real numbers except we said x cannot equal negative 3. Okay? So because I have the same on both sides, then I get all real numbers except x is equal to negative 3. baseball player's batting average is calculated by dividing the number of times a player got a hit by the total number of times the player was at bat. It is expressed as a decimal rounded to 3 places. After the first 10 games of the season, Samuel had 12 hits off of 33 at-bats. So what is his batting average after the first 10 games? So it says that you divide the number of times a player got a hit, so that would be 12, by the total number of times the player was at bat. So he was divided by 33. All right, so we take our calculator, 12 divided by 33, and it says it's rounded as a decimal rounded to 3 places. So 1, 2, 3, that's a 6, so I'm going to round that up to 0.364. All right, and I'm not actually going to put an equal sign because it's approximately, because I rounded, so 0.364, 364 thousandths. How many hits in a row would he need to get to raise his batting average to above 500 thousandths? All right, so in other words, how many more hits is he going to add to this? Well, we don't know, so we're going to say 12 plus x. But if I'm raising the number of hits that he makes, that means I'm also raising the number of times he is at bat by that same amount of number. So 33 plus x. And we want it to be greater than, because it says above 0.500. Okay? So now let's think about this. All right, how am I going to solve this? Well, we would solve it just like we would anything else. We'll solve it just like we have in our equations. So 12 plus x is greater than, and we'll do 33 times 0.5, which is 16 and a half, plus 0.5x. All right, so we'll subtract that 0.5x. So 12 plus 0.5x is greater than 16 and a half. Subtract that 12. So 0.5x is greater than 4 and a half. Divide by a half. So x would have to be greater than, so we'll do 4 and a half divided by a half. So x would have to be greater than 9. So he would actually have to bat 9 times more, and then he would actually have to make all of those, he'd actually have to bat 10 times and make all 10 hits. How many at-bats in a row without a hit would result in his batting average dropping below 0.300? All right, so it says that his batting, his at-bats is going to go up, but his hits are not going to go up. So we're going to keep that 12, and his hits are going to, his batting is going to go up. All right, and we want that to be less than, because it wants to be dropping below 300 thousandths. All right, so we're going to solve this the same way. All right, so 12 is less than, so we'll take 33 times 0.3, so I get 9 9/10, plus 0 3/10 x. All right, let's subtract that 9 9/10. So I get 12 minus 9 9/10 is 2 1/10 is less than 3/10 x. Divide by that 3/10. So 2.1 divided by 3/10. So x would have to be greater than 7. All right. So if he went 8 at-bats in a row without a hit, he would be below. So here we would need to say he needs 10 hits. And here he would need 8 at-bats. Alright? Alright, guys. If you have questions, make sure you check in with me. Do not forget what I said about attendance. You need to be checking in every day. Go on to Infinite Campus, check that participation, but make sure you're turning in your work, because if you don't turn in your work, you will not get that credit. You will be marked absent. All right, guys, have a great rest of your day.